Alright students, whoop-de-doo! This is my latest installment in Special Topics Lecture 1's coverage of a systematic review of chapters 4 and 5. In this one I'm going to teach you a doozy. It's net ionic equations. It's a big topic, but I hope that you're excited about it because I know I am. Are you ready? Bonesaw is ready. Then let's begin. According to our text, in writing equations for reactions in aqueous solution, it is often useful to indicate whether the dissolved substances are present predominantly as ions or as molecules. Let's consider this example equation, where I've got lead nitrate combining with potassium iodide to form lead iodide and potassium nitrate. An equation written in this fashion showing the complete chemical formulas of reactants and products is called the molecular equation. Now, because lead nitrate, Ki and KNO3 are all water-soluble ionic compounds, indicated by writing AQ next to them, and if you look back at the previous slide, they totally all are. We can write the equation down here in a form that indicates which species exist as ions in solution. So once again, the idea is that lead nitrate, Ki, and all these things, in fact, are all water-soluble. So as soon as you throw them into water, they'll separate out into their individual ions. So lead nitrate separates out into an individual atom of lead 2+, and two separate polyatomic ions of nitrate, NO3-. Ki, potassium iodide, separates out into potassium plus, iodide minus. Now they have coefficients of 2 in front of them just to make sure that they're balanced on both sides of the equation. But this is sort of the idea, and the same thing happens down the line. Now, equation written in this form with all of the strong electrolytes that are soluble shown as ions with little AQs next to them is called a complete ionic equation. Please note, by the way, that lead iodide shown here is a solid, so I cannot separate it out into lead and iodide ions. Now notice that K plus and NO3, that is potassium cation and nitrate anion, appear on both sides of the previous equation. Don't believe me? Skip back and look. Ions that appear in identical forms on both sides of a complete ionic equation are called spectator ions and play no direct role in the reaction. When spectator ions are omitted from the equation, they cancel each other out, and we are left with the net ionic equation, which is the one that includes only the ions and molecules directly involved in the reaction. So in this case, this would be the net ionic equation, only the stuff that directly involves any chemical reaction, and doesn't appear the same on both sides. Once again, we see that our solid lead iodide is shown here as a solid. So how in the world do we write a net ionic equation? Allow me to teach you. Step 1. Write the full and balanced molecular equation, which I showed you for this lead iodide example a few slides ago. Step 2. Use the solubility rules from table 4.1, which I'm going to show you right here, to determine which products are soluble and which ones are insoluble. Only the insoluble ones, which are called precipitates, and the ions from which they came, participate in the reaction. Step 3. Use the information from step 2 to create a complete ionic equation, which I just showed you for this lead iodide example a slide or two ago, placing AQ next to all the ions that are soluble and S next to all of the precipitates. Step 4. Cancel out on both sides of the equation any ions that are AQ on both sides, that are exactly the same on both sides. Canceled out ions are called spectator ions. And step 5, rewrite your complete ionic equation with your spectator ions removed. The resulting equation now shown is the net ionic equation. Let's take a look then at an example. I want you to write balanced net ionic equations for the reactions that occur in each of the following cases. Then identify the spectator ion or ions in each reaction. Now I'm not going to show you how to do that here, but I will post a link to a separate video right here which takes you to an explanation of how to do it, if you guys wish. Now for some tough ones. The net ionic equation for the formation of an aqueous solution of nickel iodide accompanied by the evolution of CO2 gas by a mixing solid nickel carbonate and aqueous hydroiodic acid is... this is where you fill in the blank. Whew, okay, this one might look tougher than you think, but it's really not too bad. If you can talk your way through this to figure out what these substances all are, and then compare them to what the options are down here, hopefully you'll be able to figure it out. Now, if you can't, or you're struggling with it, for those students who are taking this from me in person, I will help you address this in class. Here's another one. The net ionic equation for the formation of an aqueous solution of aluminum nitrate by mixing solid aluminum hydroxide and aqueous nitric acid is what? Once again, I'm not going to do this for you, but for students who take this from me, I will show you how to do it in person in class if you need my help. If not, then you're good to go. That takes us to the end of this video. Please stay tuned to the next video in which I will begin teaching you about molarity and how to do calculations with molarity. Until then, my beloved students, have an enjoyable and fun rest of your day.